Okay guys, before you start with your lab, your exercise, so here are some reminder. Okay, and just to remind you all, because we are going to run with AC source of induction three-phase motor, so the whole concept can be summarized like this. So you have an AC source which will be connected to your motor, and the motor will run either with loaded or unloaded. So you have a shaft and you have a load, but this load, as per previous lab, our approach is that we use mechanical to electrical conversion module such that we can connect the resistor as our electrical load here. So it means that we just change our resistor value to represent the electrical load, so it's easier to predict or easier to manipulate. So whatever current that absorbed by this resistor system, so that is absorbed from the module and it will absorb from the motor. So what you have to do is that in between the setting here, you can put your ammeter to measure the input current. You can put your ammeter to measure the output current, and you can put your voltmeter to measure your voltmeter to measure your terminal voltage. And so be reminded that in terms of current you can put in line, but for voltage, and you have to put in between the terminal. So you can put voltmeter, so volt ampere, and in terms of, so you have voltmeter here. In terms of DC, we can just multiply volt times current, you get your power. But this one will involve VI cos theta. So instead of you calculate, so you can put your wattmeter here. Also your VA meter and your var meter. All of these devices you can find inside your PCM. You go to elements, go to other, so all the sensor and probes you can choose from the drop down box here, and so you can put and select on your select and put on your system. Okay, var meter, voltmeter, and after your motor, you need to measure the torque. So you put a torque meter, and you need to measure your speed, so you put your speed sensor, and all the sensors you put in between the system. So you can represent the procedure using this, not like this one, but maybe in your own creativity, by flowchart or by blocks diagram. So this R value, I believe you already know how to adjust, because P equal to V square R. And so you know your V, so you know what your P you need to generate or apply to the load, so you can find your R. Okay, then in terms of your simulation, please in your simulation control, please be alert that you have to adjust on the total time that you want to simulate. Because why? When you simulate, for sure you see a response. What we need to understand that the system will need some time to reach the steady state. And steady state, you see, when you run this simulated under a certain load value, it takes about 2 seconds, more than 2 seconds to stabilize into steady state value and current. So it reach up to 100 ampere. By right, the current that in steady state is only, you can see over here, is only, if you measure the RMS value, 30 ampere, 30 ampere, 30.2 ampere steady state RMS. But over here, if you accidentally take the value here, you can reach up to 100 ampere. Okay, So in terms of measurement, you have to take care. Either you want to take peak value. Let's say like this, you can take peak value because the steady state is just a DC line. This one you can take peak value, but like this is AC. You cannot take average. You cannot take peak because once you wrongly pick up or probe, so the reading is incorrect. So for AC, it's better to take RMS. Okay, and you make sure that your timing or duration is sufficient enough, such that the system can reach steady state. Then you can take the reading. So the X1 and X2 should be setting between or after the system is considered steady and up to the maximum time. Okay. Okay, in terms of data that you can lump together, make sure that the range of the unit is almost the same. Like this one, torque and speed. You can see that the torque, you can see the response, but in terms of speed, the speed you can see the response. You can reach up to 1200 RPM, but torque, the value is up to 11 and 11.5, 11.48 and 11.48 Newton meter. So by that you should separate into the another graph. Okay. Okay, that's all for your reminder. So make sure that the steps that from the procedure, you transfer the circuit. The circuit, you generate the data. So you got the data, you put inside a table. Then from the tables, you generate your trend. Okay. Okay, good luck to you all. Thank you very much. Assalamualaikum warahmatullah. Okay guys, sorry. It's not V square R, but it should be I square R or V square over R. Okay. So P is equal to V square over R. So when you run at zero current, your the highest resistance, so you use that V and divide by your P, so you get your R.